Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad SYAHMI bin Ahmad SHAPAWI. Today I'm going to present to you my final year project. My final year project given by Dr. Muhammad Afzan bin Muhammad Anwar, which is my supervisor, and the title is The Impact of Posterior Tibial Slope on Anterior Cruciate Ligament and Knee Stability. Okay, for the introduction, my project is to study the relationship between the posterior tibial slope on anterior cruciate ligament. Okay, anterior cruciate ligament, which is ACL, is an important body part or ligament that keep our stability. ACL is a ligament between the two bones of our knee joints, which is femur and tibia. ACL can be injured if we do an activity that consists of huge amount of excessive force towards our knee joints, such as sports and heavy duty works or heavy duty lifting. Okay, ACL, an injured ACL can be treated using surgery that is called anterior cruciate ligament reconstruction. Some of the ACL reconstruction patients might undergo a failure because of certain reason. Okay, in the previous study, some of the studies said that the increase of posterior tibial slope is one of the risk factor of failure of the anterior cruciate reconstruction. Okay, next, the objective of my project is, the first one is to construct the 3D models of the knee joint with different tibial slope angle. Okay, my project consists of 6 different 3D models with 2 different knee flexion angle. The second one is to develop the finite element analysis, which is FEA, of the knee joint models. And the third one is to study the effect of tibial slope angle on the stress distribution over ACL. Okay, next is literature review. This is from my FYP1. Okay, I have reviewed over 20 journals, and all the journals is divided into 3 types of journals, which is, the first one is experimental, second one is clinical, and third one is simulation. Okay, this is the subtopics that I have divided in my literature review. The first one is the relationship between PTS and ACL injuries. Second one is tibial slope and its effects on force in anterior cruciate ligament graft. And the third one is modeling of knee joints anatomy. And the fourth one is finite element analysis of knee joints. Okay, this is from my FYP1. I have presented this last semester. Okay, this is my methodology. Okay, I will briefly explain my methods using my flowchart of my project, which is on the left side of this slide. Okay, the first step is to construct a 3D models of knee joint using CATIA and abacus. Okay, for this one is I have obtained a models of knee joint that consists of femoral and tibial bones only from a website called GrabCAT. So I need to add on a few parts of the knee joints that is required in my project, which is cartilage, meniscus, and the main part is ACL. Okay, next is to determine all the parameters needed in the 3D models. Okay, which is materials, load, and boundary conditions. It is important to obtain a good result, because these parameters will provide a realistic simulation. Okay, the next one is to perform the simulation and collect the data produced, and the last one is to analyze and compare the results. Okay, this is the first step of my methodology: construction and meshing of the 3D models. Okay, the construction of the 3D finite element models required two software, which is CATIA and Abacus. In CATIA, I constructed the model of anterior cruciate ligament, which is SL. As you can see in the middle, that is my model of SCL. Okay, I also assemble the SCL with the femoral and tibial bone using CATIA, because in Abacus it is very hard to construct this simple model of SL. Okay, the next one is cartilage and meniscus. Cartilage and meniscus was constructed using mesh feature in Abacus. I construct this cartilage and meniscus using a mesh feature in Abacus, which is to select one by one of the faces on the bone and construct a layer of mechanical models. Okay, next is material properties. Okay, as you can see in the picture below, that is the models that I have constructed. The green one is the meniscus and cartilage. Okay, for the properties, for the material of every part in my models, I use this data in the table, which I get from a previous study. Okay, there are a total of 5 parts in each models in my project. The parts consist of femoral bone, tibial bone, meniscus, cartilage, and ACL. There are interaction between all of the parts of the model to make it more realistic. Okay, the anterior cruciate ligament ACL is set. The ACL is set constrained as tie to the femoral and tibial bone, where both ends of the ACL is fixed using surface to nut contact. And for the meniscus and cartilage, is set as coupling using surface to surface contact and have a small sliding formulation. And for the contact property, it is set for tangential behavior with friction coefficient of 0.2. Next is a load establishment and boundary condition. Okay, the simulation in this study is mimicking the Lachman test, that is a physical examination used in clinical procedure to detect an ACL injury or tear. A concentrated force of 80 Newton is applied to the reference point in front of the femoral bone, which is posteriorly directed loaded acted on the femoral bone. As you can see in the picture on the left side, the force is directed from the front of the femoral bone. In the same step, the first boundary condition is the displacement or rotation is set to the reference point as static general state procedure. The second boundary condition is also static general state procedure with boundary condition type of symmetry, antisymmetric, and encastre has been set to the tibia bone. Okay, this is one of my results. This result shows the von Mises stress acted on the SCL. Okay, this is the overall result data that I have tabulated and plot into graph. Okay, for the results, I have divided into two types of knee flexion. Okay, for the zero flex, the most highest stress distribute is at 12 degree of posterior tibia slope. At zero knee flexion, the higher the posterior tibia slope angle, the higher the stress distribution. Okay, this finding have concluded that posterior tibia slope is affecting the SCL. The SCL reconstruction patients have an SCL that is very fragile and easily damaged. So a slight overstress can cause a rupture and tear to the SCL. Okay, for the deep bending position, which is a 90-degree flexion, the lower the posterior tibial slope, the higher the stress distribution. This is because more bending motion acted on the SCL at lower posterior tibial slope. The higher angle of PTS, the lesser the bending motion of the SCL, because the PTS is steeper and more open posteriorly, that give less stress in the SCL. That is why the 12-degree posterior tibial slope is less stress than the 2-degree posterior tibial slope. Okay, this is a video that I want to show you. This is my simulation, and this is my simulation of the results that I get from the 90-degree flexion of the 2-degree posterior tibial slope. Okay. The simulation is mimicking the Lachman test, which is the femur bone is pushed inward and the tibia bone is pushed outward. In this simulation, the tibia bone is fixed. Okay, that's all. Thank you for your precious time, and stay safe and take care of your knees. Okay, if you have any question, you can contact me through my email or my contact number as shown below. Thank you.